November 9th, 2015, I was in this story of measurement book. I'm looking over a lot of things in here. There's a lot of things new to learn. And I noticed this part on blood transfusions and how much blood is used for specific transfusions. I don't know if you guys can see that very well. I didn't know heart surgery took 25 pints. Each pint is one single donation. A car crash or gunshot victim takes 50 pints, and the most here is liver transplant, up to 100 pints. That's a lot of blood. I have O positive blood when I donate. I think I have up to 28 donations now, and it's good for young men and men alone to donate blood because of the iron buildup in our bloodstream. It's good to get the iron out. But on the note of blood, I remember I made a connection about 3 years ago with, stars in their evolutionary path. And as a young man, I've always been interested in lava. 2,000 degree rock flowing on the surface of the earth. How cool is that? And then I couldn't help but to make a connection between lava when it comes out from the earth as it goes over the surface and solidifies into large lava fields, and depending on how fast or slow it cools will become different types of crystals. I know obsidian is formed in that way. And I had to make a connection between the blood coming out of a person's body, say if you get a cut, and the blood that comes out, the lava, or the magma I should say, out of the earth. And then when it comes up out of the earth, it coagulates onto the surface and creates scar tissue, the lava fields. And I wanted to note that the stars, or the astrons that are dead, such as, Venus, Mercury, Mars, they don't have a lot of volcanoes. They don't have lava coming out of their surfaces. But the Earth does, meaning if the Earth has a wound it's trying to heal, the lava will come up, coagulate on the surface, and rebury the wound or the fissure or the damaged region. And dead stars, they can't do that. Dead asteroids, they can't do that. So that's another point. It's like if an asteroid were to hit Venus, Mars, or the Earth, or Mercury, there wouldn't be a way for the surface to recover itself, to heal itself. In other words, if something really large were to hit, it would excavate the surface, and then it would just, nothing else would happen. You would have some liquid rock from the impact, the heat of the impact, but then that's it. There would be no way for the star to repair its surface. On the Earth, in other words, if an asteroid were to hit, what would happen is the lava in all the interior regions would coagulate and encapsulate that area, and that area would heal effectively, thus almost completely getting rid of all evidence of any kind of impact event. And this is very important because in online discussions I see a lot of people ignoring the effects of lava and magma and types of liquid material being able to heal supposedly the areas which have undergone huge impact events. And as well, the younger the astron is, such as Jupiter and Saturn, and even very young astrons such as the Sun, they won't have any evidence of impacts on them. Because what happens is then when the object hits those other objects, the gaseous envelope completely makes that impact disappear altogether. It's as if nothing ever even happened. Like when you're at the beach and you put your foot in the sand, and then the water washes over the sand and completely washes any evidence at all that you were ever there. It's the same thing with Jupiter, Saturn, and large gaseous objects where there's no actual surface to create a type of scar tissue, if you will, that leaves evidence for the impact. This meaning the majority of the impacts the Earth had undergone in its past have completely been erased, because the Earth was much more gaseous in its past, and even was a very large plasmatic object similar to the Sun. And obviously the Sun would be able to erase any evidence of impact, because it's very, very diffuse, and it can just literally destroy whatever gets, becomes in its path anyways. It just ionizes the hell out of it. And brings me to another point, the question of how to define black dwarfs. I know black dwarfs are a definition or a word that I use a lot, but I'm not too sure how to define them, because a black dwarf should be something that has a crust, and I don't know if it can regenerate or not. Because there are dead asteroids, which, if something hits them, they can't regenerate. They just leave craters all over the surface like Mercury, because they don't have any liquid interior. Or, you have the Earth where you can regenerate, but it still has, like, But I just want to throw that out there. How do we define black dwarfs? Where's the cutoff for a black dwarf? Or should it be more of like an analog type definition where there's a continuum? There's no like set, this is a black dwarf, there isn't, this isn't. As well, I want people to understand that a lot of the impacts and a lot of the events that happened in the Earth's past, when it was, orbiting other stars and was a star, itself very early on in its evolution, that there's a lot of things that happened that we won't have any evidence of whatsoever. Maybe we could find isotopes of something for like evidence of different things that have occurred in the past, but you have to keep your mind open to the fact that Earth was a gaseous star. That way you can obviously interpret the evidence in the light of Earth's actual evolution, rather than, geologists assuming Earth was always solid liquid rock when it was formed. No, it was very gaseous, very large, and plasmatic at one point. So the geologists ignore large swaths of the Earth's history. So we gotta, pay attention for their myopic interpretations to make sure that we, say, geologists, you guys are, you're in your own little bubble. You don't really know what you're doing. Here's what's actually happening when it comes to interpreting the evolution of the Earth itself and its formation. As well, I would want people to look more at things like lava and the heat of the Earth, and how the heat of the Earth is convected through, and different types of heat transport mechanisms such as convection, conduction, stuff like that. And also look at the older objects as they evolve, to try to look at, Jupiter as a large object that has heat convecting all the way through its interior, and what kind of convection patterns would be there inside of that object as it forms its core, as it forms the central planet in its interior. As well, how much differentiated is the Jupiter's interior and its core versus Neptune and its interior and its core. I think Neptune is much more evolved. Uranus and Neptune are much more evolved than Saturn and Jupiter. As well, Saturn and Jupiter are obviously more evolved than younger red dwarf stars and brown dwarfs, and those are much more evolved than stars like the Sun. So you have a large continuum analog type setting. It's not digital. It's not in individual discrete steps as an astronomer or an astrophysicist would want, because they would make math equations easier. No, it's more like a continuum. It's a smooth curve, a slow, steady transitioning from one type of object to another. It's a metamorphosis, if you will. But there's just some thoughts for people today. Obviously, already get the date. Take it easy, everybody.